Okay, it's time. This is 2003, question number 16. Alright, let's get on with this program here. Alright, we're going to let f equal the function defined by this. It's a piecewise function. And the first question asks, is f continuous? Okay, so this is f. Is it continuous at x equals 3? Now, in order for a function to be continuous, there cannot be a hole there. And the left side and the right side have to be approaching the same y value. Let's take a very simple function for an example. Here's a simple function for an example. I'm wondering if we're continuous at x equals 3. Actually, let's do a different one because I don't want to confuse it. At x equals 5. So is there a hole right here? Nah. Is the left side of the graph approaching the same y value as the right side of the graph? Yes, they are both approaching the same y value. So if they're both approaching the same y value and there's no hole, then you know that the function is continuous. So that's all we have to do. That's all we have to show. So we're going to go to A. A says, is it continuous? Explain why we're not. So we're going to say, okay, well, let's go to the x as we approach 3 from the left side. And let's go to the x as we approach 3 from the right side. Okay, so if we approach 3 from the left and we approach 3 from the right, for the function f, are we continuous? So which one of these equations, this square root one or the 5 minus x, is the left side of f? Because, guys, whenever we have piecewise functions, they're broken up into sections. This one is broken up by going from 0 to 3, and then from 3 to 5. So there's a section right here, and there's a section right here. Which one of these is the left side of 3? This first one. So the limit of the square root of x plus 1. Okay, now if you don't remember, pay quick attention. The first thing you do when you are testing a limit is you just plug in the numbers. So I'm going to plug in 3. I plug in 3 to this. I get 3 plus 1, the square root of that. That equals 2. Oh, yeah, that wasn't that bad. The right side of this equation f is 5 minus x. And so when I find the limit of that, I'm plugging in 3 again. We have 5 minus 3, which equals 2. Hey, lo and behold, they equal each other. So because they equal each other, because 2 equals 2, f is continuous. Oh. Yeah. All right, let's look at the next question. Find the average value of f on the closed interval from 0 to 5. Now we find the average value. When you try to find the average of any set of numbers, what do you guys do? Add them up, then divide by the numbers, but the number of numbers that you're adding. And so f will spit out to you a bunch of y values when you plug in x's. If you plug in all these x's from 0 to 5, it'll spit out a bunch of y values to it. Okay? When this says find the average value, it's saying find the average y value. If we're trying to find the average y value, then what we need to do is we need to take all the y values, add them together, then divide by the total number of numbers that you're adding together. So let's do that. Let's take our cool calculus function that adds all the numbers up, which is an integral. Okay, that stands for an s, which means sum. The sum of what? The sum of all of the y values in f. Okay, and we can split this up. And then we're going to divide this by the number of numbers that we're adding together. Well, we can't really know the number of numbers, but we do have an interval of those numbers. It goes from 0 to 5. And actually, I think they say that here too, yeah. So from 0 to 5. So I'm going to go 5 minus 0, which is just 5. Let's split this up, though, because we have to. We have the first part of this piecewise function, which goes from 0 to 3. So we have the integral of x, what is that, plus 1 dx. And then we're going to add to that the integral from 3 to 5 of the right side, so 5 minus x dx. We know that we're supposed to split it at 3 because we're taking the integral of f, and f is made up of 2 functions. I have to integrate each of these. I know that this function is only in existence between 0 and 3 because by definition of piecewise function. And then from 3 to 5, that's the second part of my function. So now I just have to integrate this one, and I have to integrate this one, and then divide by 5, and we get my answer. Now this isn't a calculator problem, so you got to integrate this on your own. So let's see. Let's make this one. I see a function inside of a function, so that I'm thinking we're gonna have to use a chain rule. And integration, a chain rule is u substitution. So let's make u for this one equal. Actually, let's use different color for this. U substitution. We're gonna use x plus 1. I take the derivative of the left side. I get du over dx. Take the derivative of the right side. I'm going to get just 1. The derivative of x is 1, the derivative of 1 is 0. So now let's make du equal 1 dx. So it's like I multiply both sides by dx, but not really. Alright, so now I see a x plus 1 and a dx that I can sub out with the u's I got. So I got a u right here and I got a du for the dx. So let's sub those out. So we have the integral of u, actually let's make that into a 1/2 power, and we have du. My x values, which are, where are they, 0 and 3, they're changing. I have to plug them into here to change them into u's, so I'm going to have, what is that, 4 for the upper bound and then 1 for the lower bound, because when you plug 0 into the x right here to change it into a u, you get 1. When you plug 3 in, you get 4. This is all going to be multiplied by 1 over 5. I take the time to write this extra stuff because I want to make sure I don't forget anything. I don't like doing things in my head, especially if someone's going to give me a score on something. So I have 5 minus x dx. Alright, let's integrate. When I do this first one, we add 1 to this 1/2. We're going to get 3 over 2. So I have u to 3 over 2. And then we're going to divide by 3 over 2, which is the same as multiplying the top by 2, dividing by 3. And then I'm going to get, I'm going to plug in 1 and 4 because I have a definite integral. Not just going to do a plus c here. Alright, the integral of 5 is going to be 5x. The integral of x will be x to the 2nd power. Then I have to divide by 2. So you can say divide by 2 or you can multiply by 1/2. We're going to plug in the 5 first and the 3 to see what we get. And then we're going to multiply everything by 1 over 5 when we're finished. First, let's plug in the 4 to this guy. Don't worry, that rational exponent isn't that bad. I have 2 times 4 raised to 3 over 2 over 3. Now I'm going to subtract 2. Now I'm going to plug 1 into this, times 1 raised to the 3 over 2 divided by 3, plus, let's put these brackets right there, put my 1/5 right here. Man, we're getting a little crunchy right here. Alright, and then this side's going to be 5x minus, no, not x, we're going to plug in 5, not squared, minus 5 squared over 2, put parentheses around it, minus 5 times 3, minus 3 raised to the 2nd power divided by 2, well, bam. Alright, close that bracket. I'm going to need a little bit more space right here. Okay, so when you're doing, when I simplify this, you can do the power, which is the numerator of the exponent, or you can do the root, which is the denominator of the exponent first. Either one first doesn't matter. You can say 4 to the 3rd power first, or you can say the square root of 4, because that's what that 2 is, the square root. So let's square root 4. Yay, that's a 2. Okay, now we have 2 raised to the 3rd power. 2 times 2 times 2 is going to be 8. 8 times 2 is going to be 16. Alright, this is simplifying quite nicely, pretty fast. First we have 16 divided by 3 minus, and this one right here we have 1. The square root of 1 is going to be 1. 1 raised to the 3rd power is 1, so this doesn't even matter. We have 2 over 3. 1 over 5. And then on this one we have plus, okay, that's going to be a 25 up top. So I have 25 right here, and then this is 25 divided by 2, subtracting, minus, it's going to be 15. 3 squared is 9, so 9 over 2. Divide that all by 5 when I'm finished. Alright, man, we got denominators of 3 over here. We got to distribute this negative.
I'll see you later.
Later, dude. Alright, so I'm going to go minus, and I have positive right there. Let's see, let's make this into a denominator of 2, so that's going to be a negative 30. This one over here, let's just make this a denominator of 2. We'll make this a 50. Oh man, look at all this math we got to do. Getting crunchy up in here. So we have plus, that's going to be negative 30 plus 9, that's going to be negative 21 divided by 2, plus, let's add the 2 over 3, and a 16 over 3. That's negative. Wow. Wow. Look at this. Look at all this stuff. And we still don't have a common denominator. What a booger. Okay, so find common denominators. Let's do that. This is going to be, well, let's simplify this more. We have 14 over 3 plus, that doesn't look like a 3, plus, that's going to be 4 over 2. Oh, wow, that's nice. Check that out. 4 over 2 is just a 2. Sweet. So we have 2. Oh, we're adding that to that? Oh, cool. Let's just make this into a denominator of 1. We're going to make that into a 3, so this is going to be a 6. So we have 6 plus 14, which is 20 over 3. And we're multiplying this by 1 over 5. Our final answer is 20 over 15, which then simplifies down to, I shouldn't simplify it, but since I've gone this far, I did it. I'm doing it. 4 over 3. Wow, that's our answer for that. This question asks for the average y value. Boom, there he is. 4 over 3. How is this the average? It's the average because we were adding all the y values that this thing spits out, and then we're dividing it by the interval. Let's do the next one. Alright, so here we have a new function being defined for us, g. This looks almost identical to this guy up here. Same intervals, same everything, except look at this. There's a random k right here, there's an m right here. It says that k and m are constants. If g is differentiable at x equals 3, what are the values of k and m? Now, this FRQ kind of hinted to you what else you need to know in order to answer this problem. Now we have two variables that we're looking for. It wants to know k and m. Whenever you have two variables that you're looking for, you need to have a system of equations. So we need to have two equations in order to find the k and the m. Now we know that that g is differentiable. Well, if g is differentiable at x equals 3, that means g is also continuous at x equals 3. And we just did that. We just did some continuous stuff up here. What had to be true about the function if it was continuous? We had to plug in 3 to this and 3 to this, and they had to equal each other. So that's one of our equations, actually. We're going to plug 3 into that first one, which is k, so we get 3 plus 1. And that's supposed to equal m times 3. I'm plugging in 3 for the x, plus 2. So these should equal each other. Now if I simplify this, it starts looking nice and pretty. This would be 2k. And this one right here would be, well, that'd be 3m plus 2. So that's my first equation. But because we're trying to find the value of two variables, we have to have two equations. So we're going to have to come up with a different way to come up with another equation. So what I'm going to do, since this g is differentiable, that means at 3, we don't have a point, we don't have a gap, we don't have a hole or anything like that. That means at 3 we should also have the same slope for each of these parts of this piecewise function. So I'm going to take the derivative of g. Now when you take the derivative of a piecewise function, all you got to do is take the derivative of each of those functions, one at a time. Now remember, k is not a variable, so we got to treat him like a constant. So we got to take the derivative of k times, I'm going to say x plus 1 raised to the 1/2 power instead of this. And we gotta take the derivative of, oh, okay, that's better. And I gotta take the derivative of, okay, and then the next one, mx plus 2, we're gonna take the derivative of that one. So, oops. So these are supposed to equal each other. Oh yeah, and we're plugging in 3 to those. So let's take the derivative of each of those and then plug the 3 into those. So if I take the derivative of the top one, I'm going to drop that 1/2 and it's going to multiply to the k. So we have 1/2 times k. Remember, k is a constant. It's just a number right there. And then we have to let's say we have x plus 1. And then we have to take 1 away from that 1/2. So we have negative 1/2. And some of you guys are forgetting this. You're forgetting the chain rule here. Now we have to take the derivative of the inside. But actually, I guess it wouldn't matter if you forgot this one because the derivative of the inside is just 1. So we have 1 right there, and the derivative of the bottom one. Let's do that one. Let's see, if I took the derivative of mx, you would be left with m. And then if I take the derivative of 2, that would be 0. So I just get m. So these two should equal each other when I plug in x. So let's plug in x. We have 1/2 k, and then on the bottom we have the square root of x plus 1. Do you guys see why I have it on the bottom now? Because I had a negative 1/2 power, so I put them on the bottom, and it's a square root because it's the 1/2 power. This is supposed to equal, oh, let's get rid of that x. Let's plug in our 3. That's supposed to equal this m. Then the x doesn't even matter right there. Alright, so let's see. Let's simplify stuff. This would be a 4 right here. What is the square root of 4? It would be a 2. So we have 1/2 of k divided by 2. That when you divide by 2, that's the same as multiplying by 1/2. So if I multiply that 1/2 by 1/2, I get 1/4. So I get 1/4 k equals m. Here we have it, people. Here's one equation, and our other equation, let's write down here with them. Let's see, we'll have 2k equals 3m plus 2. This is a system of equations. You guys remember algebra? So I just got to take this m. I'm going to take this m, and I'm going to plug it into this m right here and start solving. So we have 2k equals 3 times 1/4 k, and then we have plus 2. So this is going to be 3/4k plus 2. We're going to move that to the other side. Let's see. Let's go. If I go 2 minus 3/4k, because I'm going to subtract 3/4k to the other side, I'm going to get 1 and 1/4 k. That equals 2. Let's see. Let's multiply. Let's make this into an improper fraction. That's going to be 5/4. Multiply both sides by 4. So I get 5k equals, what was that, 8. Then divide by 5, so I get k equals 8/5. And let's find the m. To find the m, I'm going to take this guy and plug it back into one of my 2 equations. I'm going to plug it into this one because it looks more simple. All I do is multiply 1/4 times this, so I get m equals 8/20, which you could simplify, but I'm not going to. There's our answers. Here's your scoring guide. This part's worth 3 points right here. This is how they made it look. I didn't have to simplify the 8/20. It's the same as 2/5. And there's the 8/5. You get 1 point for setting these two equal to each other. So for that first equation that I created, you get 1 point for that. And then you get another point for the other equation that I created. That was after I took the derivative and I set those equal to each other. That's another point. And then if you didn't know how to solve, the system of equations, at least you got 2 points. And then you get 1 point for the system of equations part.